Hi, everyone. Good morning, good evening, good afternoon, wherever you may be. Welcome to our live stream, and thank you so much for making the time to join us. My name is Keen Chen. I'm with the marketing team at VeloDB and Apache Doris. So today we're talking about JSON analytics and the variant data type. And we are super honored to have two Apache Doris experts today with us. They're Owen Shao, Apache Doris PMC, and Product VP at VeloDB.
Hello, everyone.
And Max Lee, senior engineer at VeloDB.
Hi everyone.
So thank you guys. So we all know that JSON is very popular these days, and it gets used almost everywhere. They're in logs, events data, e-commerce product data, IoT device data, and AI and large language model applications. But handling large-scale JSON analytics can still be quite a headache for a lot of data systems. So in today's session, Owen will first talk to you about how different data systems handle large-scale JSON analytics. He'll compare Apache Doris with ClickHouse, Elasticsearch, Snowflake, and Iceberg. And Max will show you a demo of querying a billion rows of JSON data in Apache Doris deployed on an AWS environment. And lastly, just a small note, we will do a Q&A session after the two presentations. So feel free to drop in your question anytime in the Q&A tab. You should be able to see a Q&A tab at the bottom of the Zoom screen. So type your question and we'll address them all at the end. So with that being said, I'm gonna turn the mic to Owen. And Owen, feel free to start your presentation anytime.
Okay, thank you, Chen. So, hello, everyone. I'm Owen from Apache Doris community. Yeah, I'm a PMC member of the open source project and also a co-founder of VeloDB company, which provides the commercial product for Apache Doris. Today, I will talk about semi-structured data storage and analytics, discussing the approaches from text to JSON and variant. Before I jump into the semi-structured data, let me introduce Apache Doris briefly. Okay, Apache Doris is a popular open source real-time analytics and search database. It was created by our team at 2013 in Baidu, the second largest search company of the world. It was then open source at 2017 and contributed to Apache Software Foundation. It was graduated to a Apache top level of project in 2022, the year that we start the VeloDB company. Apache Doris community is very active. Let's see some active numbers. 14 kilo plus GitHub stars, 703 contributors. Last month in a meeting, I said that I hope that one will be the lucky 700th contributor, and now we have more than 700. So the community is growing fast. And among all the Apache project, open source project, the number of page views and monthly active contributors of Doris is the highest, and even compared to Apache Spark, Flink, Kafka, and some popular project. And not only popular in developers, Apache Doris has been used by more than 5,000 enterprises all over the world. So why they choose Apache Doris? This is the answer from a real user. He said that you need Apache Doris if your dashboard refresh in real time, not in minutes. And compared to ClickHouse, Doris is better for mixed analytical workloads. For example, join, search, and real-time ClickHouse query engine. And Doris is perfect for customer-facing analytics and real-time agent-facing analytics. Okay, and let's focus on today's topic, the semi-structured data analytics. I will talk about the character and challenges of semi-structured data first, and then let's see the different approaches to address the challenges of semi-structured data, including technology and products like Elasticsearch, Snowflake, Doris, ClickHouse, and Iceberg. Then I will show the usage of Apache Doris variant. And last, I will share some typical use cases. And Maxine will also show some real-life demonstration. Okay, let's go ahead. As you know, in the data field, we often classify data into semi-structured, and unstructured data. Structured data has strict schema, for example, the most frequently used relational table. And on the other hand, unstructured data like text, image, video does not have obvious schema. And semi-structured has flexible schema, for example, JSON and XML. As you know, JSON is really popular in recent years. So when we talk about semi-structured data, what are we actually talking about? I find an explanation from Wikipedia, and I think it just sounds reasonable. It says that semi-structured data is a form of structured data that does not obey to the tabular structure of data models, and it contains tags and other makers to separate semantic elements, and it's also known as self-description structure. So as a conclusion, I summarize the three characteristics of semi-structured data. Firstly, semi-structured data does not adhere to fixed tabular structure. Secondly, semi-structured data often have self-describing and non-fixed structure. And thirdly, hierarchies are very common in semi-structured data. And according to the characteristics, there are some challenges to store and analyze semi-structured data. It's schema flexibility, storage efficiency, and analytical performance. Okay, let's explore the different approaches to handle these challenges. Here are four major categories of approaches on the coordinate system. The horizontal X is about schema flexibility, and the vertical X is about performance. As you can see, the most tool-naive approach lay in the left up and right bottom corners. The ETL approach is very high performant, but not flexible. While the JSON string approach is quite flexible, but with poor performance, especially for analytics. So the binary JSON approach appears. For example, MongoDB Bison and Doris JSONB is faster than JSON string since the binary is stored and the parsing string is a void on query, but it's still not fast enough for analyticals since the whole JSON binary needs to be read, even you just need a few columns. And then the most effective approach now is pass JSON field and store them as separate columns automatically. It's both flexible and performant due to automatic column storage. I will call it variant-like approach since many systems give it the same name. Okay, this is a comparison table about what I just talked. And one thing you should notice that what's the disadvantage of variant-like approach? What's the since it's both performant and flexible, what's the disadvantage? It's complex to implement. And you may ask that it seems to be quite simple and straightforward to pass the JSON fields and store them as separate columns. So what's the complexity? Okay. The first complexity is about too many columns. You can imagine that how to handle 1,000 or even 10,000 columns. You will get too many columns, sub-columns. It will cause some problem. And second problem is about type evolution, how to handle field type changes over time. And the third problem is index, how to index the extracted subcolumns in variant type. If you don't support index, you will not get very good performance for high concurrent queries. And last one is about controllability. Auto inference of data type and field is good, but it's not always accurate. So, can the system provide a way to let users to specify the schema and index of some fields is very important. Okay, let's continue to discuss the solution for these challenges in different systems. For a challenge of too many columns, Elasticsearch will limit the number of columns to 1,000 by default. It will reject write request if the number of columns exceed the limit, and it will cause data loss for some cases. It's totally not acceptable for serious use cases, I think. And Snowflake has a limit to 200 and store the exceeding fields to a combined subcolumn. This approach avoids data loss, but performance decrease after 200 fields. And Apache Doris does a similar job and push the limit to 2,000 by default. And some users even configure the limit to 10,000, and it works well. I think it's very good. And ClickHouse does the same job and push the limit to 1,024 by default. And for Iceberg, it's not defined in their specification since the variant type of Iceberg is still under development. Okay, and for a second problem, the type evolution. For example, for a single field ID, it was originally an integer and then changed it to a double number and then change it to a string. So how to handle the type change over time, since in most databases, the type of a field is fixed. And this is what Elasticsearch does. The type of single field is fixed when it appears the first time. And then after that, if you have a write request for the field with another type, it's totally not allowed, and the write request is rejected. So it also causes some data loss problem. And for important use cases, it's not acceptable. And for Snowflake, it does not extract the non-uniform type field. So the non-uniform type field is stored in the combined field, just like JSON binary. Yeah. So it will not lose data, but the performance decrease if the type of a single field is not the same. And in Apache Doris, you can have different types across different data files. Since different data files has its own metadata for the for the data type of the subfield of a variant. And if it's in the same single data file, there are different types. The type of the field will promotion to a wide depth. And in ClickHouse, you can have different types across different data files, and it can have different types within the single file with more metadata. For Iceberg, it's still not defined in their specification. Okay, for the index is very important for high concurrent queries, and for full text index is very important for full text search. Elasticsearch has very good support for index. Uh, since it's very famous for search and it's inverted index, it support inverted index and vector index for the subcolumns. Snowflake support some simple index. It called search optimization index, including acceleration for echo, substring, and geo queries. In Apache Doris, rich index is supported for both the top level columns and the subcolumns of variant. Uh, the index supported are inverted index, vector index, Bloom filter index, min-max index, and many more. And you can even add a job index on demand. So if you have 100 field, you don't need to add index for each field at the first time. You may add 5 index for 5 field, and then if your business involved, you can add another 10 index for another field. So most of the types of index is supported in Apache Doris. It's very important for high concurrent queries and full text search queries. And in ClickHouse, Bloom filter and min-max index is supported. Some with limited support for index. And for Iceberg, it's still not defined in the specification. And the next challenge for variant-like approach is controllability. How to let the user specify the schema of some fields. In Elasticsearch, there is a mechanism called dynamic template. You can specify the data type and the index type of a field or a pattern of fields with the same pattern. So it's very user can control can get more control, and it's very flexible to configure the name and patterns. In Snowflake, you cannot do it. It determines the data type and the data type automatically by itself. So it's not controllable by users. In Apache Doris, a similar mechanism called schema template is supported. You can specify the data type and the index by field name and patterns. So it's in this case it's equal to Elasticsearch. And in ClickHouse, you can get some simple capabilities. You can specify the data type by field name. But imagine that if you have many fields, for example, 100 or even 1,000 fields, if you want to specify the data type for the fields one by one, it's very tedious. And for Iceberg, the schema controllability is not supported now. Okay, after talk about the challenges of just the variant-like approach, next we see the performance of different approaches. In this diagram, we can see that for JSON benchmark, Apache Doris is number one. As you can see, it's it's 2 or 3 times faster than Elasticsearch, even 100 times faster than MongoDB, and even 1,000 times faster than Postgres. So if you want efficient JSON storage and analytics, you can try Doris. It definitely will give you surprising result. Okay, after discussing the tactics and challenges about variant, Let me show some usage about Apache Doris. First, when you create a table, you can declare the sum of the field, the type of some field as variant. For example, the field actor, it's a variant field without schema template. And for the field payload, it's a variant field with schema template. As you can see, the field start with bool will be defined as type Boolean, and which start with number will be defined as big int. And in the index area, you can specify the index for different types of patterns. For example, the field start with bool will have the inverted index, and the field with start with string will have two inverted index, one without tokenizer, another with the tokenizer of Unicode. So it's very, very flexible to specify the data type and the index for the fields in and patterns in variant. Okay, after you create a table like GitHub events, and then you ingest some data into it, you can get the subfields from a table using describe command. And usually, if you describe the table, you will get the field you defined when you're creating the table. And then if you set the variable to true, the describe extend variant column to true, and then you describe the table, you will get the subcolumns of the variant fields. For example, the actor.id, actor.login, actor.url, and more. Okay, so you can get all the subfields from the database. And for query, I will give two simple examples. The first one is that you can get the count the rows with payload with actor ID in payload equal to my ID. You can see that the syntax is very similar to the syntax of map tab in Doris. And in the second, more complex query, you can select some subcolumn from the payload variant column and order by and name it, and it will be much complex. And in the while clause, we use match for full text search, since we can define the full text index, inverted index for the string columns. Okay, and last, I will share some typical use cases of variant. A variant is powerful, and it's even powerful in real-world use cases. The first kind of use case is log and trees in observabilities. There are some data, some log and trees extension fields in the observability data. For example, in this case, the ext field. When you create a table, you can create it as a variant type and define some index on it, and you can query. You can get the subfield of index using the map syntax. And benefits of using variant in observability are as follows. First, it allows for field type changes to avoid data loss. Since field type change is very common in observability data, since the upstream process generate the data is not controllable to the downstream storage processing system. And second, it automatically adds and removes fields from the schema. You don't need to add in fields automatically by your hand, manually. And last is 5 or even more times higher compression ratio compared to string. So it will save much, for example, 18% of storage cost. Since storage cost is very important in observability use case. Okay. And the second kind of use case, category use case is about IoT or IoV, Internet of Things or Internet of Vehicles. Since the internet device, cars will generate many data with text. For example, in this case, the text field. You can define text as variant, and you can filter based on a subfield of the text, and you can even run some array functions such as array contains on the subfield text B. The benefits for IoT, the first one is high analytical performance compared to some time series database, since Doris is highly optimized for analytical queries such as aggregation, filtering, and sorting. The second benefit is that thousands of columns for tag evolution, since the tags, your device and cars will generate different kinds of tags over time. So the more columns the storage system support, the better the business can evolve. And the same, you can achieve very high compression ratio in this case. And the third use case for variant is SaaS company, for a SaaS company, for the customer-facing analytics. For some SaaS companies, they store their customer specified properties. For example, the property in this data in this piece of data. When you create a table, you specify it as variant, and you can specify the index for it, and you can use equal query and match full text match query for the fields inside properties. You may also get many benefits from using variant. In this case, thousands of field for customer properties, since customer-defined properties are not controllable. Yeah, it cannot be fixed. If you support customer properties, it will let your customer get better experience. The second is for rich index and high concurrent queries. For customer-facing analytics, query response and concurrency is very important, since thousands of your customers may be using your service and software to get real-time insights. And last one is about full text search and joins. For many SaaS companies, they need a database that support both full text search and joins. Since full text search is supported by Elasticsearch very well, and joins supported by database very well, but few systems support both full text search and joins, just like the example. Okay, that's what I want to share. Then I think I should give microphone to Max Lee. He's also a committer of Apache Doris project. He will share two real demonstration. Okay, Max.
Okay, thanks, Owen. Hi, everyone. Welcome to this special session on Apache Doris on AWS. I'm Max Lee, an RD engineer at VeloDB and an Apache Doris committer. Just a quick note before we start. This is a pre-recorded video tailored specially to show how Doris handles massive scale JSON analytics. We've compressed hours of data engineering into just a few minutes to respect your time. Feel free to drop any questions in the chat. Okay, let's show the demo. Hello everyone. Today we are tackling a challenge that every data engineer on AWS faces: how to query 1 billion rows of raw JSON data in seconds without complex ETL pipelines. We have developed Apache Doris on AWS and loaded massive datasets from S3 directly into Doris using the variant data type. We will show you extreme performance and intelligent search. We are using 2 real-world massive datasets for this video. Blue Sky social media data. 1 billion rows of social media events. It's highly nested and perfect for testing raw aggregation power. 2. GitHub Archive, a rich dataset of developer activities. It contains sparse, unpredictable JSON structures with commit messages and comments, ideal for demonstrating schema evolution and full text search. First, let's verify what we are dealing with. Let's check out count of the blue sky table and the data size. That's 1 billion rows and the storage size. Let's start with a high-level overview. We want to see the distribution of event types. Notice that collection is a nested field inside the JSON. Doris automatically threads this into a column. Result in seconds. Accessing nested JSON is as fast as a flat column. We are finding the first user to post on the platform. The first 3 users retrieved from 1 billion rows in sub-seconds. Finally, our most loyal users. We calculate time span between their last and first post. 3 complex queries on 1 billion rows, all answered in seconds. No ETL, just raw power. Moving on to our second dataset, GitHub Archive. We have loaded massive history of developer activities. While the volume is impressive, the real challenge here is the complexity and sparsity of the data, well, we will see next. Before we search, look at the table structure. We define some columns, actor, repo, and payload and variant. Then we set describe extend variant column equals to true and describe it again. Look at the result. Doris automatically discovered and threaded thousands of columns, like payload, commits message, payload actor, login, etc. This means you get flexibility of JSON with performance of a columnar database, no manual DDL required. Let's find issue URL, contain null pointer exception. Other databases scan the whole table, while Doris use inverted index. Instant results, we jump directly to the relevant rows. Then, let's find out who contributes the most performance optimizations. Doris combines SQL analytics with full text search match. No need for a separate Elasticsearch cluster. To summarize what we saw today, first, no ETL. We loaded raw JSON into variant type without defining a single nested subcolumn. Second, extreme scale. We queried 1 billion rows with second latency. Third, smart search. We used inverted index for instant log analysis. And one final thought. While other systems struggle with a few hundred JSON fields, Doris handles thousands or even tens of thousands of subcolumns automatically. Whether it's 10 columns or 10,000 columns, Doris keeps your data lakehouse fast, flexible, and cost-effective on AWS. Thank you for your watching. Okay, that's all I want to share.
I'm seeing an open question in Q&A. Do you want to take a look at that? And I'll launch a poll as we speak. Hi everyone. If you have any questions, feel free to drop in the Q&A tab below. We will address them. And on the screen, you will see all the different kinds of ways of engaging with us. So Apache Doris is the open source engine that powers VeloDB. And VeloDB, we offer a VeloDB Cloud, a managed cloud service for available all on different kinds of cloud services. And also, feel free to follow us on social media. We routinely share a lot of value and knowledge on Apache Doris and use cases and customer stories on LinkedIn. And it's also just a good place to have different conversations about data analytics, data engineering, and Apache Doris. Of course, if you want to get a more kind of one-on-one technical support and talk to other Doris users, you could always just get technical support. Join our Slack community to get technical support. You can either scan the QR code on screen or just type in Apache Doris community.slack.com. That's a very vibrant community with lots of users and lots of experts. So yeah, we have one questions here. I'll read it out. So how does subcolumns work in Doris? I think we have someone waved at us. Never mind. Sorry. How does subcolumn work in Doris? Do they convert all JSON fields to subcolumns automatically? And when you define a variant type, do you have to define schema and index for the JSON fields? Yes, all JSON fields can be converted to subcolumns automatically. You can choose to define schema and index, and it's on demand. Okay, so yeah, we'll give it a few more minutes just to see if we have any more other questions. And Owen, is there anything you'd like to share from the perspective, like what kind of scenario would Doris work better for JSON analytics?
Yes, as I discussed that, there are three typical use cases about a variant. The first is log and trace in observability. And second is for IoT and IOV data storage and analytics. And the third one is for SaaS company, the customer-facing analytics.
Okay. All right. Yeah, I think that's about it for today's session. Thank you guys so much for the detail sharing and the demo. And thank you so much for making the time to join us. We'll see you in our next webinars. We will have a lot more to share on Apache Doris and its AI capabilities in our future sessions. So, and again, we really appreciate you choosing to spend your time with us. Thank you guys so much. Have a good one. See you next time.